Hey guys, so you should actually already know how to do everything from this paper that you're looking at today. But I figured I'd go ahead and still do an example from each section just to kind of make sure you understood exactly what's going on and just to kind of get the ball rolling a little bit. Alright, so let's start off doing number 1, which says plot A, the polar coordinate, at the point R being 3 and the angle being 30 degrees. Okay, sorry about that. Brigham decided to come in early and I had to kick her out until 8:30. Okay. So, plot A, the R is 3, angle is 30, okay? So, R being 3 means I'm on the third circle, and it was positive 3, so I go right this way. And then I just need to go to 30 degrees. Now, you might be wondering, where is 30 degrees? Well, let's see. We have 0 degrees, 1 line, 2 line, 3 line, 4 line, 5 line, 6 line. So, how many degrees does it seem like I'm going to be going up each time? Hopefully you realize 15, because you go 0, 15, 30, 45, 60, 75, 90, okay? So 30 degrees would be 2 lines up on the third circle, so that's right there. And that's really all there is to it, alright? Let's do D, number 4, real fast too, where it asks you to plot D at 2, negative 60, okay? So, negative 60 degrees. Okay, so negative 60, well, let's see, where would 60 be? A positive 60, it'd be up 15, 30, 45, 60, so it'd be up 4 lines. So negative 60 is just down 4 lines. So you go to 2, you go down 1, 2, 3, 4. So bam, that's where D would be. Oh, I need to put A, and I need to put D. All right? Okay, let's go on. I'm going to do a problem for your next group, which says state 3 other pairs of polar coordinates for each point where theta is between negative 360 and positive 360. So our first point they give us is negative 2, 150. So let's just start off by plotting that. So you have to first ask yourself, where would negative 2, 150 be? Well, negative 2 is going to start right there, and then I need to go 150 degrees in the positive direction. So that would be in this direction. So, let's think about that for a second. We know half a circle is 180 degrees. So if we want to go 150 degrees, it should make sense to say that we just need to go all but the last 2 lines. So you could, if you want to count out, you could go 180 plus 15, which is 195, 210, 225, 240, 270. You could just, I'll jump all the way here to 270. Okay. I lost count. Crap. Sorry. Just think about it like this. What is 180 plus 150? 330, right? 330 degrees. So starting at 270 and go up to 330. Okay. So that would just be 295, 310. I lost count again. 285, 300, 315, 330. Sorry about that. Sorry that took me so long. And this would be right here on the second circle. So once again, to go back through that one, it would be negative 2. Okay, so you go back 2. And then you need to go counterclockwise 150 degrees. So you need to end up at 330. It would have been easier if I had just labeled this circle first. That's really what I should have done. But, you know, that 330, if this was 360, this would be, 345, and take away another 15 to be 330. And so that's where, now I need to get 3 equivalent points to that right there. All right? So you have to pause and think, okay, I've already done negative 2. I'll give you a hint. You want another negative 2. Okay? Now, the first negative 2 that you had gave you a positive angle. So you want a negative 2 with a negative angle. So go over here to negative 2 and think about going negatively. How many degrees is it going to take for you to do that? Well, negative 2 all the way around, that's 180 degrees, plus another 2 lines, which are each 15 degrees, okay, which are each 15 degrees, so that's 30 degrees total. So 180 plus 30, which is 210, but I did negatively, so it's negative 210 degrees. I don't have a little degree marker, but if I did, I would draw it right there. All right? Now, I'll give you another hint. You want your next point to be a positive 2, comma, all right? So positive 2, 1, 2, and let's get a positive angle. So that would be going all the way around the circle, which is just 330 degrees. And then our last point, we want to be positive 2, but we want to be negative, and it's down 2 lines. We know each line represents 15 degrees, so we know that it's negative 30 degrees. And there's your 3. Okay, so that's how you do number 10 and number 11. Let's look at problem 12. This is where a lot of you guys really start struggling. That's okay. We all struggle at times. Okay? So it says, state 3 other pairs of polar coordinates for each point where theta is between negative 2 pi and positive 2 pi. And you're going to do me a favor. You're going to change number 12 from being 4 comma pi over 5 to being 4 comma pi over 6. Okay? So I'll tell you that in class, but you want to change it from being 4 comma pi over 5 to being 4 comma pi over 6. Okay? So 4 comma pi over 6, first off, 1, 2, 3, 4, pi over 6 lands us right there. Okay, this circle is not given to y'all on the paper. I put this circle on here. You're more than welcome to use the circle I gave you the other day to use it, or just use the one that's used for degrees and just think about where they would fall for radians. Okay, so 4 comma pi over 6 falls right here. We need to find 3 other points. Well, I'll give you a hint. The first point is going to be 4 comma negative something. I want a negative angle. Okay. So positively, I just had to go up 2 lines to get to where I went. So I went to 4, and I went up 2 lines. So to go negatively, I need to go all the way around in the negative direction except the last 2 lines. So I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 lines. All right, so if I was to go 22 lines in the positive direction, that would tell me the same angle that I just went in the negative direction is just merely negative. So 22 lines going around falls at 11 pi over 6. So 11 pi divided by 6. That's my first point. I'll give you a hint for the next one. It's going to be negative 4. And let's make it a positive angle. So negative 4, 1, 2, 3, 4, and I want to make it a positive angle. So that means going this way. All right. So how many lines is it going to take to get me all the way over here? Well, I can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14. Okay, so what is 14 lines? Like, what angle represents 14 lines? We'll go positive and count 14 lines over, and you're going to land at 7 pi over 6. So, I want to be positive, right? I start here at negative 4, and I went around the positive direction, 14 lines, and I know that the angle that 14 lines creates is 7 pi divided by 6. Alright, and last but not least is negative 4 comma, okay, negative 4 comma, and I need it to be negative this time, so I want to make a negative point, okay, so I count back negative 4, 1, 2, 3, 4, and I want to go this direction, okay, so how many lines is it going to take for me to go this direction? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines, so what is the angle that 10 lines creates? 5 pi over 6. But I did in the negative direction, so it needs to be negative 5 pi over 6. And that's your 3 points. That's how that is done. Okay? Okay, so our next problem, problem 14. A point in polar coordinates is given. Convert the point to rectangular coordinates. Show work. All right, so this is a polar. This is r, this is theta, and we want to convert it to x, y. So you should just be able to look at your notes from yesterday, or remember the formulas. We know that x is simply equal to r cosine, my handwriting's bad, theta. Okay? So, r for this problem, you know what I'm going to do? I don't know why I'm drawing it. I can just use a text box. We know that r for this problem is 3, and we know that theta is just pi divided by 2. Well, you can grab a trig chart to figure out what pi divided by 2 is. So you're going to get x is equal to 3 times, so I pull up my trig chart, and I look, and I see that cosine at pi divided by 2 is 0. And 3 times 0 is just 0. So x equals 0. But now, I got to find the y point. It's the same idea, but we say y equals r sine of theta, and I know that r is 3, and I know that theta is pi divided by 2 once again. And I then look at my trig chart, and I see that sine of pi divided by 2 is the same thing as 1. And I know 3 times 1 is 3. So I know I have the point 0, 3. And that's all there is to it for that problem. That's my answer, 0, 3. Okay, let's go on. Problem 18. A point in rectangular coordinates is given. So this is an x and a y, and I want to convert the point to polar coordinates. Well, you should remember that r is simply equal to the square root, and there is no square root button, so I'm going to have to try to draw this, and I do apologize in advance. But r is equal to the square root of x squared plus y squared. And we know that x and y for this problem are both -3's. So -3 squared plus -3 squared. So that gives me 9 plus 9, which is 18. So r is equal to the square root of. So we know that -3 squared plus -3 squared is 9 plus 9, which is the square root of 18. Alright, and you know that you're going to have to break that number down. So you have to ask yourself, what are two numbers that multiply to be 18, one of which you can take the square root of? Oh, that's right, 9 and 2. Square root of 9 is 3, so we know that r equals 3 square roots of 2. So there's our r value. R is equal to 3 square roots of 2. Now, to find our theta value, I can say tangent of theta, and I actually can type theta in. So under Greek. Tangent of theta is equal to, well, actually, I can actually make it even easier. The formula tells me I can just say theta is equal to tangent raised to -1 of y divided by x. Okay? So then you would think, okay, so theta is going to equal tangent raised to the -1 of -3 divided by -3, which is going to be tangent inverse, or tangent raised to -1, however you want to think of it as, of 1. Okay? So this is where we're going to grab our handy-dandy calculator. Okay? And we're going to let it do all the thinking for us here. We're going to turn it on. We're going to hit second, tan, type in 1, press enter. Oh, let's make sure let's get our answers in degrees. I'm in radians right now. When we do radians, we like exact values most of the time. Let's do degrees. So second quit, press enter, 45 degrees. So we know, now let's pause for a second and think about what we're saying. We're saying negative, negative. Think about what quadrant that ends up in. Think about what quadrant that XY point ends up in. Fourth quadrant. Okay? If you give me the polar point 3 square roots of 2, and then you just said theta equaled 45 degrees, don't you think there's a problem there? You see how that's not going to land you in the fourth quadrant? Because that's going to put you somewhere, if you were to think about it like this, 3 square roots of 2 would put you out somewhere to the right, and 45 degrees would put you somewhere in here. But I need to be somewhere in the fourth quadrant. So, and the same idea would happen is, what if I just said negative here? What if I just made r negative? Well, negative r would put me back here, 45 degrees, would put me in the third quadrant. And that's actually where I want to be. I apologize. I said -3 was the fourth. It would be the third. I want to be in the third quadrant. Okay? So, I need to let my r be negative. Alright, so my r is negative, theta is 45 degrees. So my answer, and this is going to be poorly drawn, is -3 square roots of 2, comma, 45 degrees. And that's how you do it. Alright, I hope this works. You guys let me know if you have any questions as you work through the rest of this assignment.